This is going to be the outline for today. We're going to be talking about climate, then some of the water conditions in California, basins, all the basins that are in California, then the natural hydrology, which is something that you're already seeing here. This is the natural streamflow classification for California, and then at the end we're going to be talking about water supply and demand. So let's start. Climate. So California is located in a place where we have a Mediterranean climate. What does that mean? That we have dry summers and wet winters. It rains during the winter, so typically we will have one rain before Thanksgiving, and then we should have more frequent rains, precipitations that may come in terms of rain or snow. Late December, January, really the heavy months is late January, February, March, the first part of March, and then most of the rainfall should be gone by April 1st. So that's what we have in here now. Something that I want to talk to you is about atmospheric rivers. So atmospheric rivers is a band of moisture. So this, what you're seeing here, is moisture in the air on top of the ocean. And this band of moisture, it moves in the atmosphere as if it was a river of moisture that is traveling, and that as it is traveling, it will hit California. Now, this moisture, basically when it hits the coastal range, the moisture is coming. And as it is coming and it hits the coastal range, it will move up. And as it is getting lift, it will deposit precipitation in these areas. Then it will get into the Central Valley. It will again go down, and it will. We are not going to have that much of precipitation. This is called the rain shadow. Okay. Once it hits again the Sierra Nevada, so it will move up, and it will not only deposit rain but also snow because of the elevation, because of the temperature. And once again, once it passes the Sierras, we are going to have a rain shadow. So why is important atmospheric rivers? Because they may bring between 30 to 50, 60% of the precipitation that we have on a year. So that's why they are important. And typically they are 3-day events. So 3-day events that bring a lot of precipitation to our state and account from half of the precipitation that we have in here. If we have 2-3 atmospheric rivers, we're going to be in a drought. If we have 6-7 atmospheric rivers of 3-day events, we're going to have a wet year. So pretty much our wet season depends on 18 to 21, 27 days of rain, of effective rain, which I think is quite challenging. This is the science behind. This is what I was talking to you. The band of the moisture in the air, it will be about 250 to 350 miles. This brings a lot of water. In terms of that, it may bring up to 7 to 15 times the flow coming out of the mouth of the Mississippi River. So these are bands of moisture in the air that are bringing a lot of water. And again, it may deposit it in terms of snow or rain. Now, how does an atmospheric look like? Again, this is moisture in the air, and this is basically how they look when you are seeing them coming on. So again, this is all the moisture. It is hitting California, and as it is hitting the coast and the snow and the Sierra Nevada, is depositing all of the rain and snow. Something that you should also know is that these are also called Pineapple Express. And why they are called Pineapple Express? Because they pass through Hawaii. So that's also another typical name how we call them. So this is what I was telling you, is these atmospheric rivers. How do they look like? So let me explain you this in a graph. So this is a graph of 8 different stations that are located in the Sierra Nevada that are tracking rain and snow. Okay, this is the cumulative precipitation. So what we're doing is that we're adding, so one rain event and how much it rains to the second rain event, to the third rain event. So what we're doing is adding them up. and we're adding them as they are occurring. So that's why we have this as the timeline. Now, something for you to know is that we start the water year on October 1st. Why do we start the water year in October 1st? Because that's when we are thinking that rainfall will start. So we start from when it rains, the rainy season, and then the dry season. And again, we will start again in the rainy season and dry season. So water years typically start in October 1st. So this is the time from October 1st to September 30th of the following year. And this is the cumulative precipitation. You can see that these graphs have this kind of, they look like a stepwise figure, because basically these are atmospheric rivers. So no rain, and then one atmospheric river. The same it happened here. No rain, a big atmospheric river. No rain, another atmospheric river. Then these are smaller storms, but you can see that it looks like these steps, because basically this is when a lot of these atmospheric rains happen, atmospheric rivers happen. I know there is no normal weather in California, but if you do the average, if you do the median precipitation, this will be it, about 50 inches. And from these 8 gauges. Now, once that we are in those 50 inches, this is the driest years. And they were only 20 inches followed. So in terms of a drought, during droughts, it's not that it never rains. It's just that it rains below normal. And sometimes it will be a severe drought because it's raining way, way less than it's supposed, which is this kind of 2 dry years. Now, this will be the first year of the drought. This is the second year of the drought, the third year of the drought, the fourth year of the drought. So as you can see, they were 4 consecutive years below normal, okay? This is the 5th year of the drought, which it was just right above normal conditions. Then in 2017, we have this event where we have the wettest year on record. And then from that wettest year on record, we went back to below normal, back to wet conditions, and this is where we are now. Back again into dry conditions. In this 2019, 2020, so starting October 1st, 2019, all the way to September 30th, 2020, this is where we are. We are about 24 inches, so half of the so-called normal average conditions for California, for these regions. So let me talk to you a little bit about the snowpack. So in terms of the snowpack, this is what it's going on here. So this is the snowpack on April 2011. And why am I referring to April 2011? Well, I'm referring to this specific year. That's when I interviewed to get my job here. But I remember flying in that case, I was flying from Texas to California and seeing all the Sierras filled with snow. And I remember seeing, and that was in March 14, 16, seeing all the Sierras covered in snow. That's what I saw. That's what I saw when the first time that I fly to California. This will be the first year of the drought, and this, what you're seeing here, is the elevation of the deepness of the snow. Okay, so this is the snow depth, and the colder the colors, it will be the deepest of the snow. All the way to, these colors will be all the way to 2 meters. Pretty much 400 inches. But something that you can see in here is that how wet, how full of snow was. This will be the first year of the drought. This will be the second year of the drought. This will be the third year of the drought. This is the fourth year of the drought. So if you want to put California on its knees, take the water out of California. This is how it was so heavily stressed of water. 4 years consecutive without drought, and we had a Sierra Nevada, without snow. So that will be 2016, the 5th year of the drought, just right above normal. So this is a drought that we experienced recently here. Now, this, what you're gonna see, it is the wettest year on record. So this is when we had the most precipitation ever recorded. It doesn't look that wet, isn't it? So if you compare this 2011, that it was a wet year, but not as wet as this one, which is the wettest, we don't have enough snowpack. And so why is that? So number one is that even though it rained a lot more, or it has a lot more rain and snow, we had a warmer weather. All the snow was gone before April 1st. Why am I, all these pictures that you're seeing here are the April 1st of that specific water year. Why am I doing that? Because we consider that on April 1st, that's when we have the largest or the most of the precipitation, the largest snowfalls that should occur. They may have occurred before April 1st. So April 1st, we don't choose it because of Fool's Day. We choose it because that's the day that we think we had already the last big snow event. That's what is coming on here. On April 1st, even though it was the wettest the wettest year in here, it didn't look like that. It looks just like another normal year. Now, that was the wettest. Remember, we went back to 2018, which it was a dry year. And then once again back to a wet year in 2019. And then this is how it looks this year, which we know that are halfway of so-called normal average conditions here. So as you can also see in here, California right now is in this kind of bipolar, full of extreme modes, which is drought, wet, dry, wet. So it is yes, no, it is in this kind of very full of extremes pattern. Okay, so this is how rainfall it is distributed throughout the state. Something that I want to let you know is that it will go from, in terms of inches, 100 to 200 inches in here, all the way to less than 5 inches, so less than this much in here. So 200 inches, that should be about from the floor to the ceiling. That's how much it can rain on average on a year in these locations. Here, less than 5 inches. So you can see that we have a huge gradient of precipitation throughout the state. Now let's talk about here the basins in California. The first basin is the Sacramento, and basically that's, you can see all the different rivers that are tributaries of it. And actually the Sacramento River, the headwaters starts on this side of Shasta. The most of the water that gets into Shasta Reservoir, it comes actually from the Pitt and the McCloud. Sacramento River above Shasta is a relatively small river. And then we have Deer, Feather, Yuba, Bear, and American River. Those will be some of the tributaries. On this side, it will be Puda, Cache Creek, and so on. Now, that will be the Sacramento. Then we have the San Joaquin. And that one is, it also has, again, a lot of water coming from the Sierras, starting from the Kings, then the San Joaquin River, which is here its headwaters, Merced, Tuolumne, Stanislaus, Calaveras, McCollum, Cosumnes. The Cosumnes is actually, this river directly drains into the San Francisco Bay, into the Sacramento San Joaquin Delta, which that delta drains into the San Francisco Bay. Now we have here the Tulare Lake, which pretty much 3 main rivers, the Cahuilla, Tule, and Kern. And yes, before here, it was Tulare Lake because there was a lake where now is Fresno, Bakersfield, all of that. That was before a lake. After that, so now we are going all the way north. Here, the Smith. The Smith is worthy to mention because that's the last river that it doesn't have any heavy human infrastructure. It doesn't have reservoirs. That in that tiny corner in the northwest part of the state, that's the last river that we have without any heavy human influences. Later we have the Klamath, and the Klamath is a very interesting river. I call it an upside down river. Why I call it an upside down river? Because typically, as in the Sacramento and the San Joaquin, the river will start in a higher elevation in the mountains with a heavy slope, and the slope it will be very large, and then as it is entering the valley and it will drain into the ocean, the slope will kind of be reduced, be more gentle. The climate is all the way around. It starts in a high elevation, in a high plateau, and as it starts getting closer into the ocean, it has a steeper slope until it drains. Why? Because this is a high plateau, and then until this it will start getting into the mountains and then draining into the ocean. Here we have the Trinity Alps. So anyway, so the point is that it is an upside down river. That's kind of interesting. One of the largest rivers that we have on the state, actually the largest river that we have on the state, the Trinity, which that's this river here, and then it has three rivers, three valleys that are in parallel: Salmon, Scott, and Shasta. So basically that's what we have in there. Then we're going to have some of the North Coast rivers, which are the Math, the Eel, the Russian. The eel, there are no eels. They are lampreys, but they get confused with eels, so that's why it is called the Eel River. The Russian, they were settlers from Russia that they were living in there. That's why it was called the Russians. Similarly, here, the American River, it was because before there were some Americans living there. Yeah, this was Mexican territory, Spanish territory, so it was El Río de los Americanos, the River of the Americans. That's what is called the American River, because before this was American territory, there were Americans there, so that's why they called it the River of the Americans. Then we have all the Sans and Santas, so all the rivers related with saints. San Benito, Salinas, Santa Maria, Santa Inés, Pájaro. Basically, those are the rivers on that kind of central coast that drain directly into the ocean. South coast, we continue with the Santas and Sans. Santa Clara, Santa Ana, Los Angeles, Santa Margarita, San Diego, Tijuana. So all of those, all the Santa Clara, Santa Ana, Santa Margarita, San Diego, Tijuana, all those rivers draining into the ocean. Now, yes, one of the largest rivers on the states, the Colorado River, it passes through our state. It is actually the border between, in some cases, is between Arizona and the state of California, and in other ones is actually with Mexico. So that becomes the border. An important amount of water come from it. Then Lake Tahoe, Truckee River, Carson in this area in here. So this is the Colorado, the Truckee. The East Sierras and all the Owens, Mojave rivers. So the combination of these two actually made a distinguishable natural and a distinguishable regime of rivers in California. So what you're seeing here is the 9 natural streamflow classes of California. What does that mean? That rivers have a fingerprint and a specific signature how they actually flow throughout the year and throughout different years. So let me actually explain you how that works. Yes, here. So what you're seeing here in this eflows.ucdavis.edu, these are all the different classes, the 9 specific classes that you're seeing here. Now, all of them came because we identified 223 reference gauges, and we classified them, and in that classification, that's how we find these 9 different streamflow classes that later they were actually extrapolated and spatially, so you can actually see this pattern of streamflows throughout the state. Now, we have 3 distinctive, so 3 larger, so 9 distinctive flow regimes, but they are actually driven by snowmelt processes, rain processes, and a mixture of snow and rain, okay? So the snow processes, it will be these rivers here. So these rivers in this part of California, these will be the ones that actually have this snowmelt signature. And that snowmelt signature, it looks like this. When it doesn't rain, or well, it just, everything falls in terms of snow. And then as we approach April, May, we have all the snowmelt when it will be peak around May, June, and then all that snow starts getting going, and then the flows will go down. So this is a quintessential, typical snowmelt signature. This is the amount of, this is the flow rate. These values, this will be the median value, the 50th probabilities, the 75th, the 90th, the 25th, and the 10th percentile. So these are percentiles, and this variation tells you how much it changed throughout the years. So on this direction, you see how they change throughout the seasons, and on this, you'll see how they change throughout the years. The next one will be the rainfall rivers, and some of the rainfall flow regimes that we have in here. This is the spatial footprint. So these are mostly dominated by all these atmospheric rivers that they come, deposit all this rain, and it is driven towards the ocean. They have a different signature. They have this signature which is more jaggedy, more. It has a lot of fluctuations in here. So you can actually see that these winter storms, perennial groundwater and rain, flashy and ephemeral, rain and seasonal groundwater, it has this component of variation because when you have a large atmospheric river, it will bring all this flow and come down. But basically this kind of high variation during the wet season, it doesn't have the hump of that kind of a snow melt signature that the snow melt rivers have. And then we're going to have the ones that are a combination of both, which is this snow and rain. So these will be the ones that are snow and rainfall driven. And to me, this is like what happened if these two have a baby. So basically, they still preserve this highly variation of flow. It will have the hump. It will have this snowmelt hump that is characteristic of the snow-driven signatures. So this took us like 4 years to actually get in here. But yeah, basically you can actually see what are the different flow regimes associated with this, what you're seeing here, a rainfall and a quintessential rain and snow flow regime.